Welcome everybody to your first video in physics. It is on velocity and speed. But before we can talk about velocity and speed, I want to talk about let me go ahead and set some staples here in class. The first thing is I want to tell you that anytime I refer to anything in the x direction, we're talking horizontally. So this is my x-axis. And anytime I refer to anything vertically, I'm talking about the y-axis. And this should ring a bell to some of you, especially if you're in Algebra 2 or Geometry. I believe that's what you're working on. So this is some standards that we're going to hold for now. I might change them later, but for now, just to get started, we're going to start here. Well, before we talk about velocity, I want to talk about the difference between distance and displacement. You have to know the difference. So the first thing I want to talk to you about is what displacement is. Displacement is defined as a change in position. That means I have to pay attention to the direction that an object is moving. When a variable has a direction associated with it, we call it a vector. V-E-C-T-O-R. We call it a vector. That means that the direction matters. So for now, we're going to say that anything that moves to the right is in a positive direction, and anything that moves to the left is in a negative direction. Well, let me give you an example. So I have here a number line, and I have it marked out in meters. I have 0, 1 meter, 2, 3, and 4 meters, and to the left of it, going in the negative direction, I have -1, -2, -3, and -4. Well, I'm going to pose this question to you. Let's say I have a man. He's standing at this location, at the -2 meter mark, and he walks in a positive direction to the +2 meter mark, and then reverses his direction and stops at the 0 mark. And he makes this journey in 10 seconds. And I'm going to put this here now. It'll come into play later. So he makes this journey in 10 seconds. Well, the question is what is his displacement? Well, according to the definition, displacement is the change in the position, the difference between where he started and where he ended. And there is a nice little equation, and it's called delta x. Delta x, the change in the position, is the final position minus the initial position. So my final position is at the 0 meter mark. My initial position, where he started, was at the -2 meter mark. So if I do 0 minus a -2, I get an answer of +2 meters. And that makes sense. He is 2 meters to the right in the positive direction from where he started. That is his displacement. And when we're talking about displacement, we're talking about a vector, so we have to pay attention to the direction. Well, in physics, the direction is associated with the sign. So again, anything moving to the positive direction is to the right, and anything in the negative direction is to the left. Well, then that brings us to this idea of distance. What is distance? Distance is any motion. If he walked in any direction, we add it all up. The direction doesn't matter. And in physics, we call this a scalar. S-C-A-L-A-R. That means the direction doesn't matter. It does not have a direction associated with it. So if I were to ask you what distance did he travel, well, he traveled 4 meters to the right and 2 meters to the left. So in total, he traveled 6 meters. And you can tell there's quite a difference between 2 meters and 6 meters. This is displacement. This is distance. And these are very tricky concepts when it comes to speed and velocity. Make sure you know the difference. All right, if you want to, go ahead and pause the video and just take a moment to kind of grasp everything I said. Now what I want to talk about is the difference between velocity and speed. Right, velocity is defined as displacement over time, delta x over t. In fact, that is the equation for velocity. V is delta x over t. That means I have to pay attention to the change in the position. So let's go back to this sample that I gave just a second ago. I have this man. If you look up higher on your page, you should have this drawn. So he walks 4 meters and then turns around and walks 2 meters. His change in the position is 2 meters. So what is his velocity? Well, if I list the information that I know the change in the position was 2 meters. And he did this whole thing in 10 seconds. So the time spent is 10 seconds. So the velocity is 2 divided by 10, or 0.2 meters per second. That is his velocity. Well, let's take a look at speed. Speed is defined as distance over time. Again, if you look higher up on your page and go back to our example problem, you'll see the distance here. He traveled 6 meters and he did it in 10 seconds. So let's plug those numbers in. I get 6 as the distance and 10 is the time. The equation for speed is distance over time. 6 over 10, or 0.6 meters per second. And again, you can tell there is quite a difference between velocity and speed. We will concentrate mostly on velocity because we are concerned at the direction at which things move. Well, you can calculate velocity with an equation, but you can also show velocity by collecting data, by graphing data. So let me show you this graph really quick. This is a position versus time graph. And here is a line that shows what the object was moving. So this line is nice and straight. There is no change in the line. This signifies a constant velocity because nothing changes. At 4 seconds, he moves 4 meters. If I use my velocity equation, displacement over time, I get 4 over 4, or 1 meter per second. Let me write that a little darker so you can see it. (1 meter per second). Well, let's go to the next second. And at 6 seconds, I would go roughly 6 meters, but let's choose a point that we know for sure. At 8 seconds, I go 8 meters. So delta x over t is equal to 8 over 8, or 1 meter per second. So this object is moving at a constant velocity. Nothing is changing. So really, on a position versus time graph, the slope of this line, because that is what we found the slope, change in the y over the change in the x, the slope of this line is the velocity. So the slope of a position versus time graph is the velocity. Well, let's take a look at a few others. I have a graph of several lines. And if the slope of the line is the velocity, you can already tell which one's moving quickly, which one's moving slower, and which one's not moving at all. Object 2 is not moving at all, because his time is ticking, his position's not changing, so he must be standing still. This object is moving. As time is ticking, the position is changing a lot. And this one is also moving. As time is ticking, his position is changing a lot. Except this line is steeper than this line, so this object is moving quicker than this object. If you notice something really interesting about this graph, is that this slope is positive, so this object is moving in a positive direction. This slope is negative, so this object is moving in a negative direction. This slope is 0, so this object is not moving. The velocity is 0. You can tell the rate at which an object is going by the slope of the line, even though you don't have any numbers. You can compare the slopes and see which one is faster, which one is slower, and which one's not moving at all. Well, I hope this is a good introduction to velocity and displacement and speed. Tomorrow in class, I'll open up for questions. We can get some things cleared up. As this video was going, I hope you were jotting questions down at the side that you can ask me, and then we will use this information. Let's see how much you can assimilate in 24 hours. So I wish you luck. And again, this video is here. If you need to stop and replay, feel free. It's not going anywhere. So I will see you tomorrow in class.